Hey guys, today we're going to talk about quadratic regression and quadratic factoring, one of the most important things we do this year. So let's talk about the difference between linear and quadratic. Quadratics must have x squared as its degree. The highest power must be x squared. Whereas linear functions only have x as degree. So in other words, only x to the first, only a first degree. So how do I determine which one it is? We're going to multiply out and simplify. Let's take a look at this one. Is it linear or quadratic? Well, this is x squared minus 3x minus 12 minus 9. That's x squared minus 3x minus 21. That's quadratic because it still has an x squared in it. Let's take a look at this one. That's x squared plus 7x minus 3x minus 21 minus x squared. If I combine like terms, the x squareds will cancel out. That should tell me something. That's 4x minus 21. That's linear because the x squareds canceled out. How about regression? What's the same as linear regression, like we did with the bungee lab? We're going to use quadreg though instead of linreg. But which one? Would we use linreg or do we use quadreg? Is our graph linear or quadratic? There's two ways to find out. We can graph it or we can look at the r-square value. To graph it, we're going to plug the data into stat, edit, L1 and L2. Go to y equals, turn on plot 1 and hit enter. Zoom stat, and then look for the data and see whether it appears linear or quadratic. Or we could use the r-square value. We determine which one has the best r-square value, linear or quadratic. The best r-square value is the one that's closest to 1, or negative 1. No, I'm sorry, to 1. So let's try it. The following table shows the water level of a bottle with a hole in the bottom. The water is slowly draining out. So here's the table. First thing I'm going to do is go stat, edit, and plug it in. And to save time, I already have it plugged in. Now it says to do both ways, so let's graph it. Let's go to y equals, turn on plot 1, and go zoom. I don't know which one zoom stat is. There it is, zoom 9. And I have this graph. Ooh, that's a little confusing. It looks like a parabola. It looks like this one side of a parabola. Let's look at our regressions now. Stat, calc, linreg. I get this. And quadreg, stat, calc, 5 for quadreg. I get this. So linreg has an r squared of 0.95. Quadreg has an r squared of 0.999. This one's much better. But we've got to be careful how we write this because of this e to the negative 4. That means that I need to move the decimal 4 places. So 1, 2, 3, 4. So it's 0.000210 x squared. Let me move this over a little bit so it's easier to work with. Minus 0.103x plus 42.654. Sorry, the 4 messed up, but that's it. So according to everything we have, the quadratic is the best. Now stop and think about that for a second. Is a quadratic really the best way to model this equation? Because what would the parabola eventually do? The parabola would eventually come back up, and the water's not going to magically appear back in the bottle. So this is an example of where the numbers tell you something that doesn't make sense in real life. Okay, let's get into factoring. There's 3 types. There's GCF. It is the type that you will forget the most during the next few years of math. There's simple, and then there's slide and divide. So GCF is the most important because it's the one you forget. It's the greatest common factor. What is the common factor, or what can I pull out? In other words, what can I undistribute? Let's take a look at this one. What do they both have in common? You can divide both of them by 3. If I pull the 3 out, that leaves me an x squared minus. If you divide a 3 out, you have a 5. How could I check myself to make sure I'm right? Distribute back in and make sure you get that. How about this one? They don't have any numbers, but they both have at least one x. If I pull an x out, there was 3, there's 1 out, so there's 2 left. I pulled the 1x out, I have to put something there, I'll put a 1. Check and see if I distribute it back in, I get the same thing back. Down here, there's no number in common. 5 and 15 are in common, but this one doesn't have a number. So I have to look at the x's. How many x's do all of them have at least? They all have at least 3. So, there was 5 and 3 came out, so there's 2. There was 4 and 3 came out, so there's only 1x. All 3 of these came out, so I've got to put something there. I'll put a 1. If you want to check it, distribute it back in. So that's GCF. Now let's go with simple. That's when the number in front is 1. I'm going to look for 2 numbers that multiply to C, to the last number, and add to B, the middle number. So let's take a look at this problem. I need 2 numbers that multiply to make 12 and add to make 7. Some people are very good at this in their head. Some people have to think about it for a while. But those 3 numbers are 3 and 4. So now let's write them as factors. X plus 3, x plus 4. If you want to check it, if you distribute it out, you better get x squared plus 7x plus 12. How about this one? You have to multiply to make negative 15, but add to make negative 2. What 2 numbers multiply to make negative 15 and add to make negative 2? Well, because it multiplies to make a negative, one of them has to be negative. And because it adds to a negative, the bigger one is negative. So what 2 numbers? Negative 5 and positive 3. So now write them as factors. X minus 5, x plus 3. And yes, I could have put x plus 3, x minus 5. But the minus has to be with the 5 and the plus has to be with the 3. Slide and divide. This is the third type. This is when you don't just have 1 in front. The first thing we always have to do is make sure there's not a GCF. We're going to multiply A over to C. We're going to do simple factoring. We're going to divide the numbers by A, simplify, and then we're going to move any denominator in front of x. Let's see what that looks like. No GCF here, so let's slide this over. X squared plus 11x plus 24. Now what 2 numbers multiply to make 24 and add to make 11? 8 and 3. But in the beginning of this problem, I'm multiplied by 2. I have to undo that. So I'm going to divide by 2. Let's simplify anything we can. 8 over 2 is 4. But this won't simplify. If you still have a fraction left, we're going to move the denominator over in front of x. So x plus 4, 2x plus 3. And those are my factors. Again, if you want to check it, distribute it back out. Let's take a look at this one. Most people want to jump straight in and multiply the 3 over. No, the first step is GCF. There is a GCF. All of these can be divided by 3. Now, will this factor anymore? Yep. What 2 numbers multiply to negative 6 and add to negative 1? How about negative 3 and positive 2? And I still have the 3 out front. So this one looks like slide and divide, but it's really GCF and then simple factoring. What about some special factors? Let's take a look at this. I need 2 numbers that multiply to negative 9, but cancel out in the middle. What two numbers multiply to -9 but cancel each other out? 3 and -3. How about two numbers that multiply to -81 but cancel each other out in the middle? How about 9 and -9? So what's the general formula? When you have two things that are squared, how does that factor? X plus a and x minus a. The square root of whatever's in the second. How about this one? I need two numbers that multiply to 9 but add to 6. Well, that's x plus 3 and x plus 3. Or you could write that as x plus 3 squared. How about this one? This is going to be x plus 5 times x plus 5, or x plus 5 squared. How about this one? This is going to be x plus 1 times x plus 1, or x plus 1 squared. So that does it for factoring quadratics. This is the type of thing that we will do the rest of the year. I'll expect you to be able to do it like that. So you need to practice. Let me know. I have extra practice problems. You'll have a factoring quiz sometime in the future, so let me know. Thanks, guys.